Good morning, everyone. Hope you all are doing good. Last class, we have seen inclusion-exclusion principle. In this class, we are going to start circular permutation. In this circular permutation, we'll start with the basic, like it. This is a circle, and four people are sitting A, B, C, D. Right? In the circle, four people A, B, C, D, they have to take seats in such a way, right? Like A after this B, C, D, and that's A only, right? So what is the difference between this arrangement of four people in circle and arrangement of these four people in row, right? In a row, if they will sit, then we know that this is A, B, C, D, then A will start B, D, C, then A will start with, right, C, B, D, then A will start with D, B, and so on, right? So we know that the four people can like four people can arrange themselves in factorial four ways, right? Factorial four ways. The arrangement of four people, right? But in this case, if we are saying that A is fixed at first place, then like A is fixed at one place, then B, C, D can arrange in a way factorial 3. Because in linear form, it's start with A, but in circular form, if you'll see, it will not start with any A or B or C or D, right? It's not starting with any A, B, C, or D. So we have to fix one position. We have to fix one position so we can say कि around this A, other persons can sit, right? So every row-wise arrangement starting with A, if I'll fix this A, right? That will be all going is a one way of arrangement of circles. Means if we are able to arrange in factorial four ways, when we will divide this by 4. Why dividing this by 4? If A at the first place, right, A is fixed at the first place, then B, C, D has to, right, arrange themselves, right? They are arranging themselves in this order, right? So if we have to arrange in a circular way, to, then for n person, we have to arrange total, right, is 3 or something. So n minus 1 factorial. We have to fix position of a person. We have to fix a position of a person, then only we can go for other person. That's called the circular arrangement. So we have to convert linear arrangements into circular one. So every time when we have to fix this, we have to arrange linear and circular in a way or two, right? So what we have to consider first, for an circular arrangement, it will be n n minus 1 factorial, right? This is n different things we have to arrange. If we have to arrange r things in circle out of n, so it will be, first we have to select by NCR ways into r minus 1 factorial, right? Into r minus 1 factorial. Once we have arranged in circle, then further arrangement will be as linear one, right? Third point, please note down everyone, for circular arrangement. First two arrangement, first two statements in this case are very simple, but you have to take care. Like first is given as for n arrangements, right? For n circular arrangement, this will be n minus 1 factorial, right? For second, if you are going for out of n only, we have to select r and arrange, this will be ncr factorial and r minus 1. But for the third one, if we are saying like we have to arrange few things in circle, then again we have to arrange few things in between them. Like if I'm giving you one circular arrangement of 5 Indians and 5 Americans, in such a way Indians and Americans are sitting side by side, right? Or alternatively. So first time when we are saying ki like Indians has to sit in circular arrangement, so we know that by formula, right? For n circular arrangement, they will arrange themselves by 5 minus 1 means factorial 4 ways. Now we have 1, 2, 3, 4, 5 position, but now first you have used this for circular. So second, when we have to use this, so you have to be careful. You have to be careful. Now in this case, this is not circle because we have already used the position. We know that like if he is Indian 1, so Indian 1 right side is this position, left side is this position. So second time when this will go, so that's written there. Once we have arranged it in circle, then further arrangement will be as linear only. Further arrangement will be as linear only. So this will be by factorial 5 ways. So our answer in this case will be factorial 5 into factorial 4, right? So this is one of the example when we have to do both the things, right? Linear as well as circular arrangement, right? Third is the most important thing. Once we have arranged in circle, then further it will be as linear one. I have given you the example like 5 Indians and 5 Americans have to sit in a circle in such a way Indian and Americans are sitting alternatively. So first time when we are putting these five Indians in circle. So first time they are going into circle, then they will sit in a 5 minus 1 factorial ways. So this is factorial of 4. But Once we have arranged them in circular way, so now we have the specific position of all the 5 seeds. So this will work as a linear. So in this case, Americans can sit there by factorial 5 ways. So 4 factorial into 5 factorial for this case, right? This is the third one. And the fourth one. Fourth one is very interesting part of circular arrangement. See, if we have to arrange n different things all at a time, when clockwise and anti-clockwise are taken right as same, means if the arrangement is given of A, B, C, D, and the arrangement of A, B, C, D, right? After a flip flop, if you are getting both the arrangement and we are treating both the arrangement as one, right? After flip flop, like when we have to make the garland, when we have to make the necklace, right? So in those cases, when uh, like A have the same neighbors, we are not taking twice, right? B and D. A has the neighbor B and D, right? D has the neighbor A and C. B has the neighbor A and C, right? So same neighbors are not sitting by, right? Both the neighbors are not sitting by. If all those conditions, as I said, first is for necklace, second is for garland, third is the same neighbors. In those cases, when after flip flop, both the arrangements are same, then total number of arrangement for n people will be n minus 1 factorial by 2. N minus 1 factorial by 2. Okay, now, so these are the 4 conditions, right? One more condition is there when uh, the identical things are there when we have to arrange, but later on we will do that, right? First, we are going for only these 4 conditions. So starting with first, 5 Indians and 4 Australian are sitting in a round table. First condition, no restriction. Second condition, all Australian must be together. Third condition, all Indians must be together. Fourth condition, no Australians are sitting together. Only fourth. Try the space. We have to take care of the arrangement, like in this, the total arrangement, the circular arrangement, the condition is given like 5 Indians and 4 Australians, right? Total number of people are 9. They have to sit in a circle, and there isn't any restrictions. So we know that 9 minus 1, 8 factorial will be the answer for first one, right? For the second one, all must be, right? All Australian must be together, right? So these 4 must be together, right? 1, 2, 3, 4. Right? These four must be together, and Indians are sitting there. 1, 2, 3, 4, 5. Right? 5, and we are taking this as 1. Right? 1, 2, 3, 4, 5, and this is 1, 6. So this will go with 6 minus 1 factorial, right? 6 minus 1 factorial. So arranging 5 Indians and 4 Americans all are together. But these 4 Australian, American, Australian, whatever it is given, they can arrange themselves in factorial 4 ways. If I have used one circular arrangement, then next time these 4 will be going for only factorial 4 ways, right? So first arrangement is for the circular one, but second, they can interchange themselves by factorial 4 ways, right? Third one, all Indians must be together, right? 5 Indians, 1, 2, 3, 4, 5. These 5 Indians and 1, 2, 3, 4. 4 Australians are there, right? So all 5 must sit together, right? So this is 1, 2, 3, 4, 5. First, they will go in a, right? First, they will go in an arrangement of circle, right? These 5%, we know that 5 minus 1 factorial, that's factorial 4 ways, they can go in a circular way, but these Indians, they can sit, right? So now this is not circular one, right? They can then interchange themselves by factorial 5 ways. So again, we are getting factorial 5 and factorial 4 on this, right? Now, this is the third one. And fourth, no Australians are sitting together, right? No Australians are sitting together. So first I have to go with the Indians, right? So Indians are sitting there as 1, 2, 3, 4, 5. 5 Indians are sitting there, right, in factorial 4 ways. Now, we have 1, 2, 3, 4, 5, 5 position, right? 5 different position. One, they have used a circle. So second time, it must not be a circle. So out of 5, we have to select 4 position for Australians, and in those 4 position, they can sit in factorial 4 ways, right? Factorial 4 into 5c4 into factorial 4, right? This is for the fourth one. Hope everyone is getting this and getting the right answer. Going further with this, right, we are going one set of question again, like first, how many ways can we arrange 6 different flowers in a circle? Find number of ways of making garland. 20 persons are sitting in a circle, including A and B. Find total number of arrangement such that first AB must be together. Second, 4 peoples are between A and B. Third, AB are not sitting side by side. Very simple question. Maximum you have to take 4 minutes for this, right? Then we'll go further. So only we have to arrange, like in the first case, we can say a, for first this will be factorial 5, but with Garland this will be factorial 5 by 2, right and left. We have not to decide there, right? Second question, A and B must be together. So if A and B are together, so like 18 different people are there. So total number of people in this case, if A and B we are taking as 1, so this will be factorial of 19 for arrangement of 20, right? 20 people. But we have the case when A and B are together, so total 19 people are there. So you must go for factorial 18. But A and B are also arranging themselves by factorial 2 ways, right? First on this. Second, 4 people are between A and B. So first, out of 18, we don't have idea who is coming in between, right? Be careful. So 18C4, we are selecting 4 people, right? A, P1, P2, P3, P4, and B. Now they have to go in a circle, right? So this counting as 1, right? So A, P1, P2, P3, P4, B is 1, P5, P6, P7, P8, P9, P10, 11, 12, 13, 14, 15, 16, 17, and 18, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? So we can see there are 15, right? Different groups are there because I'm taking this as 1, right? And these 15, right? These 15 groups, they have to sit in factorial 14 ways. But these 4 person can interchange themselves by factorial 2 ways, and A and B can also interchange themselves by factorial 2 ways. So total will be 18C4. First, I'm selecting 4 people out of 18. Now they all are sitting. It's taking as group. This group is as 1. Then we have, right, 18 different 15 different groups, and they can arrange themselves in factorial 14 ways. Now P1, P2, P3, P4, they can arrange themselves in factorial 4 ways, and A and B can interchange themselves in factorial 2 ways. So total number of arrangement will be something like this. Is it okay? Right? This is the second one. And A and B are not sitting side by side. So either we can go by like in this circular arrangement, there are P1, P2, P3, P4, P5 up to P18, right? In any circular arrangement, if 18 people are sitting there, right? So if 18 people are sitting there, so first they will go with factorial 17 ways. 18 people have to sit in a circle in factorial 17 ways. Now A and B are there, right? A and B, how many positions are there where these A and B, the two people A and B can sit? So in circle, if 18 people are sitting, so they are getting 18 gaps. Out of these 18 gaps, they will find two of them, 18C2, and they can arrange themselves by factorial two ways, not sitting together, right? Or what we can do, right? Total number of people are 20. So in factorial 19 ways they can arrange. And if A and B are together, we know that this is factorial 18 into factorial 2, right? So this is total number of arrangement. This is total number of arrangement, and this is the arrangement when A and B are together. You can go by both the ways, right? So this is for you. Right? So this is about the arrangement, right? Right? The same way, if in a circular arrangement, if I'm saying one, two, three, four, five, six, seven, eight, nine, 10. The regular decagon is this one, right? In this regular decagon, with the vertex only, these are the vertex of this. Right? In this regular decagon, let's suppose this is a regular decagon. This one is there, right? So in this regular decagon, right, with the vertex, we have to form a triangle. Triangles with the vertex. First question. One side of decagon same as triangle. One side of decagon is the side of triangle, right? The side of triangle. Two sides of decagon is the sides of triangle. No sides of decagon is the side of triangle, right? Just simple one. So if we are saying that triangle with the vertex we have to form, so like the triangle, if I'm forming this triangle, so obviously no side of the decagon is a side of triangle, right? First case, when one side of the decagon, the side of triangle, right? We have 10 sides. So if I'm selecting any one side by 10C one ways, see if I'm selecting this one, right? So now if only one side is common, so I'm not selecting these two. So already we have selected 5 and 6 and not selecting 4 and 7. So we are not selecting these 4 points. So we have only 6 options. Out of 6 we have to select one when one side of decagon is common to the side of triangle, right? Second case, two sides will be common to the side of decagon. We know that this we are forming a triangle, right? In the same way, if I'm taking the vertex 1, 2, 3, 2, 3, 4, up to 10, 1, 2. So we have 10 options. So I can say total number of options will be 10 in this case. Third case, total number of triangles will be 10C3. Out of these, right, 10C1 into 6C1 when one side is common, and 10 for two sides are common. So 100% this is the answer for no side is common to the side of decagon, right? Okay, next. But I'm changing the question this time, right? Careful. 5 red points and 4 blue points are on a circle. Find number of number of convex polygon whose vertex are among the 9 points and having at least one blue point. One blue point vertex. Read this question at least twice or thrice, then go for this. We have to form convex polygon and concave polygon. First, you have to understand this word concave and convex. Convex is, right, regularly what you are taking, that's called the convex one, right? It could be go in any way, anywhere around, right? This is called convex one, right? Now, triangle we know, right? These are called the convex one. Anyhow, you can go for this. right? But if I'm taking this one, right, this is called concave, right? When this angle is going more than 180 degree. But this type of triangles, right, this type of quadrilateral are always convex one, right? But if I'm taking this vertex going down there, so you can see one of the angle is going more than 180 degree, then this is known as concave, right? So convex means this type of figure would be there, right? So be careful on that part. And uh, remember this thing, if in a circle, if you are making such type of any type of, right, with any arrangement, if you are taking out of 9 points, if you are taking few points and going for that, so 100% always you will get the convex one, right? So no worry, in convex one, 4 blue points and 5 red points are given, and we have to make convex polygon. Convex polygon start with triangle and goes up to right 9, all the 9 points up to nanogon, you can say, or the all the 9 points, right? So maximum 3 minutes for this question, then I'll start. Now we have to start this with triangle, right? 9 points are given. Out of these 9 points, 5 red, 1, 2, 3, 4, 5, right? And 4 blue, so 1, 2, 3, 4, right? So out of these 9 points, we have to select, right? Case first for triangles, right? We know that triangles and at least one blue points must be there, right? So total number of selection is 9C3. But in these 9C3, all those cases are there where we are taking all the points as red one. All 5 points are there of red. If I'm making triangles from the 5 red points, so obviously we can't take that. So we have to subtract there, right? Case 2, after triangle, I'm going for quadrilateral. Quadrilateral again 9C4. Out of 9, I'm selecting 4. But one case is there when we are saying if all the 5 points, red points are there, and from those points only 4 points I'm selecting, so I'm not getting anything from there, right? Pentagon, pentagon, it will be again 9C5 minus 5C5. But after this, we don't have, like for hexagon, because only 5 points are given. So 9C6, 100% every time will select at least 1 point that must be blue. Now, and heptagon, this will be 9C7, right? Octagon, 9C8, and the nanogon is 9C9. If we'll add all this thing, right, you're getting your answer for any circular arrangement. Okay, so this is about circular arrangement, right? Right, one question we are doing there for the circular arrangements, right? How we can arrange all this thing, right? If I'm saying A, B, C, D, E, F. These 7 letters we have to arrange in circle, right? 2 A's are there, right? So in how many ways we can arrange these 7 into the circle, right? Don't worry, this is the same case what we have already did. So if I'm taking this as even A2 and going for that, 1, 2, 3, 4, 5, 6, 7, right? 7 minus 1 will be the 6 factorial, but these two will not interchange by factorial 2 ways, right? So we have to restrict the arrangements, right? Now, the next thing what we are going to do is linear equation solution. Linear equation solution. Like if I'm saying x plus y plus z plus u is equal to 12, where x, y, z, u are belongs to whole numbers, how many different possible number of solution will be there? Number of solution in this case, right? Note down, please. Going to explain. This is the case for whole numbers. See, method first. X, Y, Z, U. X, Y, Z or U that belongs to 0, 1, 2 up to 12. It can start with 0 and goes up to 12, right? To 0, 1, 2, 3 up to 12 we can take, right? So one of the way is the called the mathematical way. Mathematical way is like counting of this X, Y, Z and U. If you want to count, right? This will be 0, 0, 0, then 12, then 12, 0, 0, 0, and so on, right? Then 1, 1, 10, 0, then it will interchange in that way. So the lot many options will be there. One case will be there 3, 3, 3, 3, right? So it's very difficult part to like how to count this, right? So what we can do if we are thinking, okay, right, I'm taking this as the base of alpha. Understand this carefully. This as a base of alpha, like x can take alpha to the power 0 means 1, alpha to the power 1, alpha to the power 2, up to alpha to the power 12. I'm taking these numbers x as an base of alpha to the power 0 of this. Similarly, y's again can take alpha, alpha to the power 1, and alpha to the power 12. Right? I'm giving the base of alpha. Right? Why I'm giving? Just I'll explain this for Z also and for U also. Right? So if I'll take x is alpha to the power 0, alpha to the power 1 up to alpha to the power 12, same as y, same as z. So this having power 4. And what I have to find, if I'm saying I'm taking 2 from this, 6 from this, 4 from this, so 0, it has to come from this. So overall, I'm saying x is 2, y is 6, z is 4, u is 0. That is the same case as this x contain alpha to the power 2, y contain alpha to the power 6, z contain alpha to the power 4, u contain alpha to the power 0. That is one of the case, right? So if I'm taking the powers, so that's always easier for me to solve this, right? So I'm like, we know that if you have to add 4 numbers, right? So directly you can add 2640, or what we can do, right? Alpha to the power 2, alpha to the power 6, alpha to the power 4, alpha to the power 0. That also give you the same result as a power, right? So if I want to just go for like go for the powers, it's given as alpha to the power 0 to alpha to the power, right, 12. In this case, alpha to the power 12 to the power 4. If I'll expand this, I know the formula. This is GP, basic GP formula. 1 minus alpha to the power 13 to the power 4 upon 1 minus alpha to the power 4. In this, what we required? So we required 12, right? Alpha to the power 12 in this case. So coefficient of alpha to the power 12 in the expansion of this. Obviously, 1 minus alpha to the power 13 to the power 4, that will contain only 1, and again, this will go for the further terms. But 1 minus alpha to the power minus 4, if you remember this, we have already solved this question or this type of question, right? The expansion of this. 1 minus alpha to the power minus 4, right? To alpha to the power r, CR, and plus 4 minus 1. Or you can say n is 4 there. So r plus 4 minus 1. This is the expansion of this. इसका expansion r is equal to 0 to infinity तक you can go. And for this case, minus 4, I'm taking as plus 4. So this is alpha to the power r, CR, right? R plus 4 minus 1, that's r plus 3. So r plus 3, right? This is coming as r plus 3 CR alpha to the power r, and this expansion is nothing but 1 minus 4c1 alpha to the power 13 plus 4c2 alpha to the power 26 and so on. If I'll multiply both this, 1 into this number will be there and other will be like all the numbers are going beyond alpha to the power 13, so we'll not take that. So our answer is r plus 3cr alpha to the power r, right? And this alpha to the power r is nothing but 12. So 12 plus 3, 15c12 or 15c3 is your answer. This is the complete thing, right? Please go through this, right? Note down carefully, right? Then I'll explain once again, right? With the base of the numbers. Please note down carefully. This is the first method, how you are getting and just how you are solving this. Now, method second for the same question, if I'm saying plus like the same thing, x plus y plus z plus u is equal to 12, right? X plus y plus z plus u is equal to 12, and then we have to solve for, right, x, y, z, and u. 12, right? So what I'm saying, there are 12, just this 12 things are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Now, we have to divide into 4 parts. So what I'm saying, if I'm taking 4 separation, so for 4 separation, I need 3 separators. For 4 separation, I need 3 separator. Separator means, right? If these 3 lines are there, means this complete thing is divided into first, second, third, and fourth part. So if 3 separators are there and the number of articles, just 12 are there, so directly we can say if 3 separators and the 12 articles are given, right? 12 articles are given. So the number of ways these 12 articles and 3 separator can arrange, that will be our answer, as 3 separator are identical and 12 things are identical. So the total number of ways in this case will be 15 factorial by 12 factorial 3 factorial, or this is 15C3, or this 15C12, both are same thing, right? But the condition is, this is the condition, maybe the separator would be first is there, second is there, third is there, and fourth is somewhere else, right? So again, this is divided 1, 2, right? 3 only now. 1, 1, 2, 3, 4, right? This 3 I'm saying, okay, that contains 0, right? If 2 separators are side by side, so this contains 0, nothing is there. So that's always included in this case, right? So total number of arrangement in this case will be 15C3. Second method, go for the third one. Hope you love the third one again. Third method. X plus y plus z plus u is equals to 12. If x, y, z, the condition is there, must be whole numbers, means it must start from 0, right? It must start from 0. Then answer will be 12 plus 4 minus 1, C4 minus 1. I guess one of the simplest way to just go for this. Directly you can write down your answer. 12 plus 4 minus 1, C4 minus 1. Right, I guess all the method clear. The third is directly you have to write down the answer. So this is 12 plus 4 minus 1, C, right? 4 minus 1. This is the separation method. Separation method is like, if I'm saying you have to write down x plus y is equal to 10, right? And xy can start with 0 and goes up to 10. So what I'm doing, first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And only I have to give one separator. If I'm giving one separator, means with one separation, you can see there are 2 division. One is this one and second is this one. So in how many ways I can give the separation will be your answer. Or we can say ki arranging 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this 11 as 10 identical, 1 identical will be your answer. So 11C1, right? And you can see by third method also 10 plus 2 minus 1, C2 minus 1, right? Or we can say from the basic method alpha to the power 0, alpha to the power 1 up to alpha to the power 10, going for twice, we have to go for alpha to the power 11. So this is 1 minus alpha to the power 10, the whole square, 1 minus alpha to the power minus 2. Again, this will go for 11. So again, this will only 1 will be from there. And this is 11C, 2 minus 1 will be 1, right? So this is the method, right? You can use the formula. The restriction is this must be whole numbers, right? So one question I'm giving you, just everyone careful and write down for this. X plus Y plus Z is equals to 15 X, Y, Z and U. Oh, U is not there. Must be whole number. Whole numbers. Right? All three. Directly, we can write down the answer, I guess. Right? So directly we can write down the answer as the first one, 15 plus 3, 18, 17C2, 20 plus 4, 23C3, 10 plus 1, 2, 3, 4, 5, 14C4. Right? So this is the way, but the restriction is you have to start with the whole numbers. But what if I'm saying x plus y plus z is equal to 10, where x, y, z belongs to natural numbers. X, y, z belongs to natural numbers, right? So if x, y, z are natural numbers, so the first method, right, we can start with the basic one, right? In this case, it will start with alpha to the power 1, alpha square, alpha to the power q, up to alpha to the power 8 only, or you can go up to 10. No, like for x, then y again, for z again. So this alpha to the power 1, alpha to the power 2, up to alpha to the power 8 for x, for y, as well as for z. right? So the GP series will be alpha cube 1 minus alpha to the power 8 to the power 3 upon 1 minus alpha to the power minus 3, right? In this, what we required alpha to the power 10, right? Alpha to the power 10. So alpha to the power 3 itself is there. So from this, I required alpha to the power 7. Alpha to the power 7. In this expansion, we know that first term will be 1, second will be 3 alpha to the power 8, and all the terms are greater than alpha to the power 7. So we have not to take other terms of this, right? And this, we know the formula for this is 2 plus R C2 or CR, right? Alpha to the power R, summation of this, right? What we required alpha to the power 7, if I'll put R is equal to 7, this is coming as 9C7 or 9C2. This is the first method. Please note down carefully. We'll go with the second and third method also, but this is the first one that we should go for. Hope everyone done with this, right? Now, the second of this is when we are saying x plus y plus z is equal to 10 and x, y, z are natural numbers, right? X plus y plus z, x, y, z belongs to natural numbers, right? So 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, in this case, we can understand by this, like each bag contain at least one ball. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 gaps. In 9 gaps, we have to give 2 separators. We know that in 9 gaps, we can select 2, and in these 2, we have to give the separation, and that will be like one is there, other is there. So it divided into 3 parts, and everywhere you'll get at least one number is there. That's the reason this for natural number, this can go. This is the second method, right? First, put all the dots, then select in between, not the case of the extreme one, and put the balls on that, right? For natural numbers. But the best method is the third one. How this is the best method and how you can solve by this. The third one, x plus y plus z is equal to 10. X, y, z belongs to natural numbers, right? So if x I'm taking as t1 plus 1, y is t2 plus 1, z is t3 plus 1, right? So if x is t1 plus 1, so t1 must be greater than equal to 0, t2 must be greater than equal to 0, t3 must be greater than equal to 0, right? These 3 cases are there, right? So if in place of x, y, and z, I'm putting t1 plus 1, t2 plus 1, and t3 plus 1, I'm getting t1 plus t2 plus t3 is equal to 7, right? And T1, T2, T3, any is whole number. Now I can apply the formula 7 plus 3, 10 minus 1, C. 3 minus 1, that's 2. That is 9C2. So I can convert these terms into the whole numbers by taking the substitution, right? And directly we can write down the answer. This is the best method for any number, natural number starting greater than equal to 2, 3, 5, minus 1, minus 2. Any case, we can convert the numbers starting from 0 and apply the formula gently. Is it okay? I guess to everyone. Note down, please. Like if I'm giving the question directly into this, x plus y plus z is equals to 20, x greater than equal to 2, y greater than equal to 4, z greater than equal to 1, right? Find number of solutions on this. Try to write down answer, write down your answer, solve this properly. So how we can go for this, right? So if you'll see this, right, three cases are given, and in those cases we have to take care how to go for that. So first is x is equal to t1 plus 2, y is equal to t2 plus 4, z is equal to t3 plus 1. So if I'll write this, so this is t1 plus t2 plus t3, 4 to 6, 7 is 13. Now, any ti is like greater than equal to 0, the whole numbers. So directly you can use this 3, 13 plus 3, 16, 15c2. Is it okay? Right. So how to reduce it down, right? For whole number, right? That is the case only. And if we know okay, how to reduce down for this, so again, we can go for that, right? So like if I'm asking okay, x plus y plus z plus u is equals to 44, where x, y, z and u belongs to odd integers starting from unity 1, right? So how many number of solution would be there? Right? To go for the odd one, right? As the you can see in the previous question, what we did, like x greater than equal to 2, right? X greater than equal to 2. So I'm taking x is equal to t1 plus 2. So t1 would be greater than equal to 0. So x would be greater than equal to 2. X, similarly, the y is greater than equal to 4. So y I'm taking as y is equal to t2 plus 4, right? Y as t2 plus 4. So t2 greater than equal to 0, then y greater than equal to 4, and same for this one, right? Putting all the values in place of x, y, and z, I'm getting t1 plus t2 plus t3 as 13. And we have solved the question of this, right? In the same way, just I'm giving x, y, z, and u is 44, where x, y, z, and u are odd integers, right? So start with this. So obviously, for odd integers, we know that x I can take as where t1, right? Similarly, y as similarly z and u, right? If I'll put all the values to t1 plus t2 plus t3 plus t4 plus 4 is equal to 40. 40 minus 44, right? 44 cancel out. 20 means t1 plus t2 plus t3 plus t4 is equal to 20, right? 20 plus 4 minus 1, 23c3 would be the answer, right? So when we have to go for the odd one, all four odd, so or even or something, right? So we have to reduce this down to greater than equal to 0, this one. If I'm able to reduce down this at t greater than equal to 0, then we can go for the answer always. Okay. Last of this type I'm doing, and hope everyone will get that answer. Then it will be easier for us to go ahead. X plus y plus z plus u. X plus y plus z plus u is 12. X greater than equal to -1, y greater than equal to 2, z greater than equal to -4, u greater than equal to 6. Find total number of solution for this case. So directly you can write answer in this case also, right? T1 minus 1 plus T2 plus 2 plus T3 minus 4, T4 plus 6 is equal to 12, right? 4, 5, right? This will be 1 plus 2, 3, this will be 9. T1 plus T2 plus T3 plus T4 is equals to 9. 9 plus 4 minus 1, C4 minus 1 is your answer. 12, C3. Right? So such type of question, when you have to only see the number of solution, right? But all the cases, in all the cases, what we have seen, the coefficient of x, y, z, and u is unity, right? What if the coefficient would be more than that? X plus y plus 2z, right? 2z is equal to 10. So see, x plus y plus z was okay, right? No problem with that. But x plus y plus z, 2z is equal to 10. Now you have to solve this and you have to go for the solution of this, right? If I'll go with the basic one, I know alpha to the power 0 for x, alpha to the power 1 up to alpha to the power 10 I can go if x, y, z are whole numbers. For y again it will go, but for z, if alpha to the power 0, 2 into alpha to the power 0, it's okay, right? So second number will be alpha square, alpha 4, alpha 6, alpha 8. Only the even numbers will be there. So the total number of solution would be not same in this case, right? Total number of solution will not same in this case. This is the first thing, right? So next question will start from here only, right? And the dice problem, okay?